Hi everyone, Mr. Eric Kwa here, founder of Mr. Khemistry. Hope you're enjoying the videos that I've made for you specially. Remember to tap that like button and to click subscribe and to share with your friends if you found any of these videos useful or interesting. I look forward to seeing you around. Let's get started with today's topic. Hey everybody, so today we're going to go through our macromolecule quiz. This is on the story of nylon. So the first part here, right, it is the context, or rather the setting of the question. Usually for such database question, right, the first part of it is basically just telling you, okay, so this is the setting, this is the background of the story. So nothing much to it, you can read through. But we first need to sit up and take note of this when they first started to describe the nylon 66. Okay, so you have a diamine dicarboxylic acid to make polyamide. Okay, so we call this nylon 66. Then they proceeded to tell you why is it called nylon 66. So the systematic name, right, the first number refers to the number of carbon atoms from the diamine, which is this part here. Okay, so there are 6 carbon here, which is involved in the diamine, part of the diamine. Okay, the second part is where you have your carboxylic acid, these two parts, dicarboxylic acid, and they say this refers to the second number. So the number of carbon here is also 6. Okay, 1, there's 4 here, and there's 1 here. So total of 6 carbon for the dicarboxylic acid. Okay, then they give you another example, right, to illustrate the naming process. How do they name the nylon? So nylon 510. Let's look at this nylon 510. The structure, emphasize again, 5 carbon atoms from the diamine. So there's 5 carbon here within the 2 amine groups, the diamines. Right? And then here, where you have the dicarboxylic part of it, dicarboxylic, you have 1 here, 8 here, and 1 here, giving you a grand total of 10 carbon atom. Okay, so you see the name, right, has to do with the number of carbon atom in the diamine, and then in the dicarboxylic side of the nylon molecule. Right? So I hope you can see this, the way that they name. First part, diamine, how many carbons? Second part, dicarboxylic acid, how many carbons? Right? So if you got that, let's move on. Okay, they say nylon 6 was invented. This made from a single monomer that has an amine group on one end, carboxylic group on the other end. Okay, so here you have a amine group, then here you have carboxylic acid group. Okay, one on each end. Right? So you can get the repeating unit for nylon 6 from there. Okay, and then of course you have your nylon X and nylon Y also given. Okay, let's read on. Okay, so you have a nylon X. Nylon X, how do you name this? Later on, they're going to ask you. Nylon Y, how are you going to name it? Okay, so they give you a table of all the melting points. And basically, they tell you about the uses of nylon. Okay, so basically, what are they used for? This you're supposed to actually have memorized it before coming for the exam already. Then after that, they say to be suitable for making fibers, they need to have a relative molecular mass of between 10 to 20,000. Okay, so this gives enough strength but still flexible enough. So this number here is very important. You need to take note of that. Okay, after that, they say how to dispose of it. Okay, do not break down easily. It can be disposed by burning at a high temperature. Okay, But they give off carbon dioxide. Disposal has a carbon footprint. Okay, so here again you see they boxed up carbon footprint. Okay, what does it say? Mass of carbon dioxide given off per kilogram of nylon. Okay, last but not least, they talk about the carbon footprint can be calculated considering the amount of carbon dioxide given off by each repeating unit of nylon. So here they give you a equation, right? Basically telling you, okay, so how much carbon footprint can be calculated by considering the amount of carbon dioxide that's given off. So this has to do with the calculation of the carbon footprint. So take note later on if the question asks you about carbon footprint, we got to take this into consideration. Alright guys, let's look at the questions, how to name nylon X and Y. So to refresh your memory, right, let's take a look at what is X and Y. So here you have your nylon X. Okay, so how do we name? Earlier on, the question already told us the first number, right, has to do with the diamine side, how many carbons are there. So there's 4 carbons here. And then we look at the dicarboxylic acid side, how many carbons are there? Grand total of 6 carbon, right? So let's look at nylon Y. How many carbons are there in total? Grand total of 11 carbons. Okay, 11. Let's write it properly. 11 carbons. Okay, 10 here and 1 carbon here. Okay, let's go back to the question. So that is indeed how we will write down nylon X and nylon Y. Okay, part B says give the structural formula of the two products that form when nylon 510 is left in contact with a strong acid. So if you look at nylon 510, right? 510, where is nylon 510? Okay, right here, nylon 510. Get rid of all the markings first. So when you leave it in contact with a strong acid, right, what's actually going to happen is that there's going to be a cleavage of your amide linkage. Okay, your amide linkage. Okay, so how is it going to cleave your amide linkage, right? You're going to add back the water, which is H here on the amide group, and OH here on the carboxylic acid group. So basically what you are going to come up with, okay, apologize, on this side as well. I'm going to add in a H, then this side you're going to add in a OH. Right, so the whole thing you're going to draw is this whole part and this whole part. Okay, so that is the structures of the two monomers that you will get if you hydrolyze them. Okay, so here you are, the two monomers. All right, so let's move on to part C. Company wants to use nylon 66 to make fibers. Calculate the minimum number of repeating units which must be present in one chain of the nylon 66. Okay, so nylon 66, you want to make fibers, right? Remember, if you want to make fibers, you need to have at least this number of relative molecular mass. So let's go with the smaller number, the minimum, 10,000. MR minimum, MR of 10,000. In order to have MR of 10,000, right, you need to calculate the MR of the monomers first. All right, so we'll just add up the monomers, the repeating unit, I apologize, for the nylon 66. So 6 here, 6 here. Nylon 6 here, 6, 6. Okay, so in all these atoms, right, we're going to find their AR right here from a periodic table, and we add up to get the MR of one repeating unit. Okay, so this is the MR of one repeating unit. Okay, so how many repeating units do we make to do we need to make the fiber? Okay, so earlier on we going to use the 10K number, right? So 10K divide by, this is the minimum, divide by the MR of one repeating unit, 226. We're going to come up with this number, 44.25, which rounds off to 45. So you need at least 45 repeat units times 45 to get one single fiber. All right. So that's for question C. The article says D, for nylon made from two different monomers, melting point is affected by chain length of the diamine and dicarboxylic acid used to make the nylon. How is the melting point of the nylon affected by the carbon length of the diamine and the dicarboxylic acid used? Explain your reasoning. Okay, so for this, you got to make use of this table here. Okay, ask yourself, okay, so how does the length of the diamine or the dicarboxylic acid affects the melting point? So if you want to look at the difference, right, you look at this first number here and you compare that with a different first number. Okay, nylon 66 compared to nylon 46. So if there is a drop in 2 carbon, right, for the diamine side, diamine part of the molecule, what happens to the temperature? The temperature actually, the melting point went up by 6 degrees Celsius, right? So we got to quote these numbers, we got to quote these examples and these numbers. Okay, likewise, you do the same for changes in the dicarboxylic acid. Okay, so if you erase off all this, let's take a look. If we change the dicarboxylic number 6 to 10, right? What happens? Okay, when you increase the carbon, okay, the number of carbon for dicarboxylic side, what happens? The melting point decreases by 49 degrees Celsius. Okay, increase 4 carbon, take note, increase 4 carbon, decrease 49 degrees Celsius. Right, so in our answer, we can quote, right? We can quote the melting point. Okay, there is a decrease with an increase in number of carbon for diamine. Okay, how about for dicarboxylic acid? Melting point also decrease from 269 to 220. Okay, when you increase the number of carbon by 4. Alright, so in order to score all 3 marks, right, you not only have to give the trend, you have to explain with data. Okay, explain with data from the question. Okay, so for data-based question like this, right, where there's a long prose, you have to read through the question and apply the information given, the data given, to answer the question where appropriate. Alright, so let's move on to ask question. Calculate the carbon footprint of nylon 6. Okay, so carbon footprint, if you remember how to calculate, you have to find the mass of carbon dioxide given off per kg of nylon. Okay, so we got to find for 1 kg of nylon, okay, means 1000 grams. How many moles is that? Okay, how many moles is that? In order to find that, we take mass, okay, which is 1 kg, divide by the MR of the repeat unit, okay, which in this case it is 113. All right, so you take, sorry, you shouldn't use 1 kg, you should use like 1000 gram. Okay, so 1000 divided by 113, you're going to get about 8.8496 moles. Okay, so that's the number of repeat units. So based on the chemical equation given, right, from the question, if let's say here n equals to 8.8 something, so how many moles of carbon dioxide do you have? Okay, so 8.8 something times 6, okay, because there is mole ratio is 1:6, right? So nylon 6 is equivalent to 6 carbon dioxide from the equation. Okay, so 1 of nylon 6 will give you 6 carbon dioxide. Okay, so you need to take that and then you multiply by the MR of carbon dioxide, which is 44. Okay, so that will give you the mass of carbon dioxide, not nylon 6, carbon dioxide. Okay, so this is the carbon footprint of nylon 6. That's it, guys. Hope this helped.